Welcome back to Patch Math, where today we are going to continue to patch your math knowledge over factoring polynomials. Moving on to the factoring by grouping method when we have an odd number of terms. In this case, we are looking at 3, but you can use the same method to 3 or more odd number of terms polynomials. In this case, we are dealing with 3 terms with our highest exponent of 2. So we are factoring some quadratics. If you are factoring a quadratic, we do use factoring by grouping. But in order to get those groups, we've got to have an even number of terms. So we use the AC method to get that even number of terms. Now you'll have teachers teach this to you when A is 1 and when A is not 1. The pure math method behind both versions is exactly the same. This will work for both versions if A is 1 or A is not 1 or some other number of 1. So I'm just going to launch right on into it. Looking here, when we find AC, that is A multiplied by our C term, where A is the coefficient in front of our x squared, B is the coefficient in front of our x, and C is our constant. Looking here, our AC is negative 18. You do take the sign that goes with the number. Negative 18 times 1. So we're looking at the factors of negative 18 that add up to our B of negative 7 there. B equals negative 7. The reason you're seeing me make a little table like this, I like to list off the pairs until I find one that works. Factors of AC that add up to B. So the obvious ones, 1 and 18, we've got, or we have to have a negative number. So 1 minus 18, it doesn't work that way. We can use the reverse of it as well. Negative 1 plus 18. Neither of those work. All right. That's okay. Well, then we got 2 and 9. So 2 minus 9. Ding, ding, ding. We have a winner. 2 times negative 9 is negative 18. And 2 minus 9 is negative 7. So that is our factors of AC that add up to B there. Now the reason we want to find the factors of AC that add up to B is that we're going to use those factors to split our B term into 2 parts. So looking here, we're going to split this B term into 2 parts. Everything around it will be the same. And those 2 parts are going to come from these factors. Now, because they're both going to have an X on them, because combining like terms says that in order for these terms to combine together, they have to have the same exact variable with the same exact exponent. In this case, we want the variable of x to the invisible 1 power, or just x. And so we can put the 2 in front of this one and the negative 9 in front of this one, or vice versa. It doesn't matter. It's important to note this is positive 2. All right. Now the rest is just as it's written. That x squared will come on down. And that negative 18 will come on down as well. All right. And now that we have that, suddenly we have 4 terms and we can go into our factoring by grouping. As you'll see, I went ahead and brought on down the steps for the factoring by grouping method. We've got the 4 terms. We've got it in order based on degree. And going from there, we will split it down the middle into its 2 parts, its 2 groups. Looking there, you'll just see that I took the x squared plus 2x and put it in its own parentheses. Now this is a polynomial. This is added to the right-hand side. Now that right-hand side, both those terms are negative. We want to make sure those signs will stay negative. if we were to simplify this back out, which is why we put a plus here in front of that binomial. Now that we have the two groups, we can cover up the right-hand side, looking only at the left-hand side for a moment, and finding the GCF of the left-hand side. So finding the GCF of the left-hand side. We do not have a number in common. We have 1 and 2. The GCF of 1 and 2 is 1, so we don't need to pull it out here. But we do have x squared and x. The GCF of x squared and x is x, because the largest amount of x's we can evenly divide into both parts. And that will leave us with x squared divided by x is x, and 2x divided by x is 2. Now, we can cover up the left-hand side and focus on the right-hand side for a moment. And if we'll see here, yeah, we have this plus sign we can bring on down, and I'm going to. But if we do, we look in here, we know our goal on the factoring by grouping method is to get that common binomial. All right, we want that common binomial. And so sometimes we want to strategize. Our binomial here is positive, but both of our terms here are negative. So we're going to want to factor out a negative sign. So we factor a negative sign out to this positive. You'll see a positive times a negative is a negative. So we can change that to subtraction. 9 will divide evenly into 9 and 18. So our GCF of the right-hand binomial is negative 9. If we factor negative 9 out of both of those two parts, we will find negative 9 divided by negative 9 is 1. And 1 times x is x. Negative 18 divided by negative 9 is a positive. And 18 divided by 9 is 2. And now we can uncover the full thing. And the goal was to have a common binomial that we can divide out of our two parts. And you'll see here our common binomial in part 1, common binomial in part 2. We can factor that multiplied binomial, or that multiplied part, definition of factoring there, multiplied part, out front. And when we factor that multiplied part out front, what remains is the x minus 9. And there you have it, the final factored form of the above quadratic using the AC method and factoring by grouping. Thank you so much for your time.